Today's lecture, we're going to start with a focus on logarithmic functions. And not just a focus on, that's pretty much all we're going to talk about. We're talking about logarithmic functions today, and in the next lecture, we're going to continue on this. So this isn't one of those, oh, I just won't pay attention because I'm never going to need it again things. You're going to need it again. Next time you're going to need it is in section 4.3. So definitely make sure that you get what we're doing now. All right, so first of all, let's pose a question. So how do I solve x squared? Let's do x cubed. X cubed equals 8. If I wanted to solve x cubed equals 8, I'd probably say, no big deal. I can do that. Hopefully you say no big deal. I can take the cube root of both sides, and I get x equals 2. Good? Alright, so what did you do? Let's actually think about this for a second. What you actually did was you said, whether you thought about it or not, is you said, well, I have a function, x cubed, and I need to undo my function. Now, what do we call functions that undo other functions? We had a whole, section or chapter on it. We call this an inverse function, right? It's a function, an inverse function undoes the other function. So if x cubed is one of the functions, the inverse is the cubed root. No problem, right? Well, here's what's the deal we run into. Say I wanted to solve. So how do I solve not x cubed, I just did that. 3 to the x equals 8. You say, yuck, I don't know. So how do I solve 3 to the x is 8? And you say, well, I can't take the cube root of both sides. You can't do this. Please don't do this. Definitely don't do this. That doesn't work either. Basically, you need a new function. I can't do it. I have f of x, 3 to the x, but I don't have an inverse function. So, you're not alone. Nobody had an inverse function for this. So finally, they came along and said, we got to come up with something. So they made up a new function, and this function is called a logarithm. So a logarithm, and I'm going to call it log from now on because I'm super lazy. A logarithm is, in fact, the inverse function, is the inverse of an exponential function. So the only way to undo an exponent is to take the log of it. Alright? So here's your official definition. If you have something like b to the y equals x, another way to write that, and in reverse, is to say y equals log base b of x. So again, how we said this is y equals log base b of x. Y equals log base b of x. This thingy down here is called the base of the log, just like this thing right here is the base of the exponent. Something that you'll notice is that over here, the b and the y are on the same side. Over here, so b and y are on the same side. Over here, b and y are on different sides. And that's kind of the point of what we're doing with the exponential, with the inverse function, is we're trying to separate things out so that maybe we can solve it in a way that we couldn't before. Okay, so let's look again at what we had. What problem did we have before? We had 3 to the x is 8. All right. So we had 3 to the x is 8. So one way to do this is by blunt force observation and say, okay, well, over here, my thingy up in the corner, my exponent, was off by itself right here. The exponent was by itself. The exponent here becomes by itself over here. So my exponent here becomes by itself over here. The base of my exponent becomes the base of my log. So the base of my exponent becomes the base of my log. And the number that was off by itself became the thingy I was taking a log of. the number by itself became the thingy I was taking the log of. So now, believe it or not, you actually have an equation for x. You've solved for x. That doesn't really mean a lot to you maybe, but you could plug that into a calculator, a good calculator, and find the answer. So way back when, you know, just like you had to memorize your times tables and your subtraction and adding and all that stuff, nobody ever memorizes their log tables. Some logs you can figure out, but most logs people don't want to memorize because they're really, really long repeating fractions and nobody ever memorizes them. But what they used to have are like books full of logarithms. So you have a book and you do a little bit of messing with this and you basically look up log base 3 of 8. If you have a special kind of calculator, you might be able to plug this into your calculator, but we're not going to assume that you do. But it's really kind of cool because, you know, now you have this, have this answer that you solved for x, and that was something you couldn't do before.